Hello students, welcome to Spectra Education Academy. In this video, I am going to explain the answers for the remaining questions which are given in previous NEET exams from the chapter System of Particles and Rotational Motion. In the previous video, I explained question number 11. Now question number 12. Three objects, first object is solid sphere, second object is thin circular disc, and third object is circular ring. Each have the same mass and radius capital R. They all moving with, or let us say rotating with, same angular velocity omega about their own symmetry axis. The amounts of work done required to bring them to rest would satisfy the relation. So get back, work done means it is change in the rotational kinetic energy. So work done is equal to change in the rotational kinetic energy half I omega 2 square minus half I omega 1 square. So they mentioned that coming to rest means this part does not exist. So anyhow, speed decreases, that is angular speed decreases. So first let us discuss for the case of sphere. Half I omega square. So moment of inertia for the case of solid sphere, in case it is rotating toward the diameter, is 2 by 5 mr square. Then with the same angular velocity they mentioned omega square. So here the important part is this 2 by 5. Then so coming to the disk. So same formula, but moment of inertia about an axis passing through center perpendicular to the plane for the disk is mr square by 2 with the omega square. For the case of circular ring, therefore half into, for the case of circular ring, moment of inertia about an axis passing through the center perpendicular to the plane is mr square, omega square. So therefore here, for the case of ring, it is the omega square and half is same there. So only it is 1. For the case of, you can take the ratio also. Omega ring is equal to omega ring is to omega ring is to omega disk, because 1 by 2 is 0.5. Here this is 1. Then next is 2 by 5. 2 by 5 is 0.4. Omega disk, then omega sphere. So look at this. So it is other numbers 1 by 2 and omega square is same for all. The only thing is that mr square. So it will be 1 is 2. This is going to be 0.5. This is going to be 0.4. So you can say that 1 is greater than all these. So therefore, for the case of ring, it is omega c, that is greater than for the case of disk. So disk is 0.5. So which is greater than 0.4, omega b. Then this is also greater than 0.3. Okay. So this is for the ring. So first option is correct. This is given in 2018. Moving to the next question. This is related to total kinetic energy, because translation and kinetic both are involved. So 13. A solid sphere is in rolling motion. In rolling motion, the body possesses translational kinetic energy as well as rotational kinetic energy simultaneously. So the question is the ratio of translational is to both translational and kinetic, rotational kinetic for the sphere. So first let us write translational kinetic energy, Ke translation, that is translational kinetic energy is simply this half mv square. Now the total kinetic energy. Total kinetic energy includes the translational and rotation. It is going to be half mv square. This is the kinetic energy of the center of mass. Also, it possesses half I omega square. So therefore, changing this I omega square, I as mk square and omega square can be written as v square by r because v is equal to r omega. So therefore, taking out common half mv square. So this is going to be, this we make it a small m, then 1 plus k square by r. So this is the expression for total kinetic energy. As I mentioned, the rolling body is sphere. Therefore, Ke translational is to Ke total Ke, that is Kt plus Kr is, therefore you can write half mv square is to half mv square 1 plus k square by r square. So therefore this will cancel. This is going to be 1 is to, so let us talk this 1 plus k square by. So we get back the radius of gyration for the sphere in case if it is rotating about an axis passing through the diameter is 2 by 5 mr square. So this m and m get cancelled. So k square is equal to, this is going to be 2 by 5 r square divided by r square. This and this get cancelled. So this is going to be 7 by 5. So it will be 1 is to, this is going to be 7 by 5. Otherwise, so you can say 1 divided by, because the ratio can be written in the division 7 by 5. So 5 will go up 5 by 7. So second option is correct. So this is given in 2018. Then moving to the question number 14. A solid cylinder, mass 2 kg, radius 4 centimeters, is rotating about its axis at the rate of 3 rpm. So torque is the question. Solid sphere. So therefore, get back the formula directly. Torque is equal to I alpha. For the case of solid cylinder, is almost similar to disk. Moment of inertia will be mr square by 2 and alpha. So alpha we need to find out because they mentioned omega in the question. So making the omega and theta. This is nothing but after 2 revolutions we got theta mentioned. So we have an equation to get the alpha value. Omega 2 square, omega 1 square is equal to 2 alpha theta. So separately this 2 alpha theta can be written as 2 pi n. So this is number of revolutions. And stop means final way angular velocity becomes 0. So it is anyhow the torque is to stop the rotation of the solid cylinder. Therefore negative only next time. So it is going to be torque is equal to mr square by 2. Now alpha can be omega 1 square divided by 2 into 2 pi n. Okay, so m is given 2 kg, r is 4 centimeter, but here in the formula we have r square, so this is 16 into 10 to the power of minus 4, conversion of centimeter into meter. Then here, so this is 3 rpm given. So remember, in general when revolutions per minute given, so this is how to find out omega is, so 2 pi f, this is for 1 second calculation, but they mentioned minute, so make it 60. So dividing with 60, so omega 1 square, so you can make it as 2 pi into 3 divided by 60. Therefore, this is 6 10. So pi square by, this is going to be pi square by 100 Again, there is one more division here, 2 into 2 pi n. How many rotations? So here 2 pi revolutions. 2 pi revolutions. Instead of calling rotations, you call it as revolutions. So pi square get cancelled. Then next this is 2 get cancelled. This is 4. So this will be 4. So 4 by 100. Yeah. There is one more 2 here because 2. 3 2s are there. Here m is 2 only, fine. So this is going to be 1600 into power minus 4. So omega square is pi square by 100. So there is first 2 here. There is one more 2 here. Therefore 2 pi n. So therefore 2 pi is, this is 2 pi. This is n is mentioned in the question, 2 pi revolution. So therefore 2 get cancelled. This is 4 8. Then this is going to be 2. So pi square get cancelled here. Therefore you get 2 into 10 to the power of minus 6 Newton meter. So torque is measured in Newton meter. So second option is correct. Moving to question number 15. This is given in 2019. A disc of radius 2 meters and mass 100 kg rolls on a horizontal floor. Its center of mass has a speed 20 centimeter per second. How much work is needed to stop? So therefore, it has rolling motion, means what? It possesses total kinetic energy. So that is, just now we did one question. mv square, it includes kinetic, translational as well as rotational. So if you take out common half mv square, you will get k square by r square. So once again, you write down translational kinetic energy plus rotational kinetic energy I omega square half. So half mv square plus half, this I can be written as mk square with the v square by r square. So if you take out common v square, you'll get back this step. Then half. M is mentioned in the question, 100 kg. V is 20 given, but we have v square. So it will be 400 into centimeter, means centimeter square minus 4 into 1 plus k square by r square. So 1 plus k square by r square. So for the case of disc, I is equal to mk square, that is equals to mr square by 2. So m and m get cancelled. So therefore this is going to be 1 plus. In place of k square, we need to write r square by 2. So there is a denominator r square. So therefore r square get cancelled. So here it is going to be half into 1, 2, 3, 4. So this minus 4 get cancelled into 4. So this is 1 plus 1 by 2 means 3 by 2. So 4. So it is going to be 3 joules. Second option is correct. So this is given in 2019. Moving to the next question. Two particles of mass 5 kg and 10 kg respectively are attached. So you can understand. So this is the rod. So here 5 kg. Then here 10 kg. At the ends of a rigid rod of length 1 meter of negligible mass. The center of mass of the system, the 5 kg particle is nearly at a distance of. So and this is able to produce anti-clock sense of torque. This is able to produce clockwise sense of torque. So the moment the torque, net torque about center of mass is net torque is 0. So net torque is T1 tau 1 minus tau 2. This is equal to 0, means you'll get tau 1 equal to tau 2. Therefore, M1G R1. So you call this is distance R1. You call this is distance R2 from the center of mass is equal to M2 R2 with a G and G get cancelled because this is weight part M1 R1. Also you can mention that The distance between the two particles is b. So keeping this in mind, we can write that R1 plus R2 is equal to 2. So the question is here to find out distance from the 5 kg mass. So therefore, we need to find out R1. So to get R1, you replace R2 with D minus R1. So M1 R1 is equal to M2 of D minus R1. So therefore, what we can write is, you can take M2 R1, after expansion, you can get it left side, M1 R1 plus M2 R1 is equal to M2D. So taking out common R1, so this is we are looking for, it is M2D by M1 plus L2. Now you substitute the values. M2 is 10 kg. D is 1 meter. So options are given in centimeters. So converting 1 meter into centimeters means 100 centimeters. Divided by masses are 5 and 10. So 15. This is going to be, yeah. Otherwise we can directly cancel it. It is 1000 by 15. 15 6 of us. 96 left. Roughly again 6. So make it 100. Again 6. So roughly it is going to be 67 centimeters. So third option is correct. Moving to the next question. Question number 17. This is given in 2020. Find the torque about the origin when a force of 3 joules Newton acts on a particle whose position vector is 2k. So therefore, get back the formula. Torque is an example of cross product between two vectors, the position vector and force. So we have to follow matrix method. I, J, K. So therefore, R is 2k, making I and J 0. So this is 2. And force part, it is only J. G means 0, 3. Under J only we can write 3. It is 0. So this is going to be I of. So when you talk about I, you should forget this column and this row. So 0, A, B, C, E. AD minus BC. So BC is 6 minus J. When you write J, column under J and row. So this is A, B, C, D. So 0, 0. This does not exist. Plus K into. So when you take K, this column and this row, so therefore A, B, C, D. So this is 0, this is 0. So 0 minus 0. So J and K does not exist. The answer is minus 6I cap Newton meter. So third option is correct. Moving to question number 18. I think this is a question based on principle of moments. A uniform rod of length 200 centimeters and mass 500 grams is balanced on a wedge placed at 40 centimeter mark. So the fulcrum is at 40 centimeters. Remember, from one of the end of the rod. Mass of 2 kg is suspended from the rod at 20 centimeters and another unknown mass M is suspended from the rod at 160 centimeter mark as shown in the figure. Find the value of M such that rod is in equilibrium. So therefore, you remember, so principle of moments is moments, sum of algebraic sum of moments anti-clockwise is equal to sum of moments clockwise. So remember, so this is the rod. So weight acts at the center. So in case it is 200 centimeters means the weight to act at roughly 100 centimeters. So what is the weight of the scale is 500 grams. So 500 grams. So here is not the fulcrum. Fulcrum is at given. This is 0. Fulcrum is at given at 40. Here is fulcrum. Now, at 20 centimeters, there is a mass of 2 kg suspended. This is from the end 20 centimeters from here to here. So here is the fulcrum, means fulcrum is at 40. So therefore, then this gap we need to take here. So this is at 100. Weight is acting, weight of the scale is acting at 100 from the one end, 100 centimeters in particular. There is one more weight at 160 mark. So that mass you need to find out. So every measurement is from the fulcrum, get back the moment, principle of moments. First one, for the case of 2 kg body, it is R1, F1. In case if this is able to produce anti-glass sense of rotation, and both the weight of the scale as well as the unknown mass produces clockwise rotation. So therefore, R2, F2, this is for the case of scale, plus R3, F3. Important thing is measurement of the fulcrum from each weight. So R1 is 40 minus 20 from the fulcrum only. So because from the end fulcrum is at 40 centimeters, but this weight 2 kg at 20 centimeters. So the distance from the fulcrum, so 5 voted point about which the rod is in rotation. So it is 40 minus 20 centimeters. So minus 2 into, so since it is the weight mg, so g is the acceleration due to gravity, that is 10. Is mentioned in the question. So this anti-clock rotation part is over. Then R2. So you treat it as this clockwise sense of rotation. Now rod is involved. R2 is 60 minus, because this is 100. 100 minus from one end, this center of mass of the center of gravity of the rod is at 100 centimeters, but fulcrum is at 40. So the gap between the center of the rod and fulcrum is 60 now. So this is 60 into 10 to the power of minus 2. The distance part is over. So weight is 500 into 10 to the power of minus 2, because it is in grams, and a g, acceleration due to gravity, plus R3, because this is at 160 from the end. This is at 160 from the end. So fulcrum is at distance of 160 minus 40 is 120. 120 into 10 to the power of minus 2. Then weight. So you are going to find out m and g. So 10 you can cancel after you take out common both sides. Even minus 2 also you can take out common and you can cancel both sides. Yeah. Next, after this, you can make a 0, 0, 0, minus 2. So this is going to be 40. And this is going to be 300. 65 300 is equal to 12. So therefore, this is yeah. So here we cancelled this minus 2, and this 10 is already cancelled. That is gravity part. So this is going to be 0.5, because there is minus 1 still left. So 0.5. So therefore, this is going to be 30 only, plus, then this is 10, and here in the calculation, this 0 will continue to have. This 0 will continue to have. Check the calculation. Minus 2, cancelled both sides. 10 also cancelled both sides. So therefore, this will continue. This is 120 m. So this is finally going to be 40 minus 30 is 10 is equal to 120 m. So 0, 0 cancelled. So m is going to be 1 by 12. So fourth option is correct, I think so. Moving to the next question. Question number 19. From the circular ring of mass capital M and radius capital R, an arc corresponding to 90-degree sector is removed. The moment of inertia of the remaining part of the ring about an axis through the center of the ring and perpendicular to the plane of the ring is k times mr square. So this is the moment of inertia, k into mr square given. So the value of k. So first thing is basic formula of the ring. Moment of inertia of the ring about an axis passing through the center perpendicular to is mr square. So, but they mentioned this is k mr square. We need to focus on getting the value of getting the equation of k. We'll see. When 90 sector is removed, means 1 quadrant almost. Suppose this is the ring. So removed means we need to find out mass of the removed part. So we can say dm by dt is equal to m by 2 pi. So therefore, 90 removed means this theta can be pi by 2 radians. So dm by pi by 2 radians is equal to m by 2 pi. So therefore, this pi and pi get cancelled. This 2 will go up. So will come down. So it will be dm is equal to m by 4. So then the remaining mass remaining is equal to m minus m by 4. So total mass is m. The mass of the removed part is m by 4. So you will be left with 3m by 4. So now the moment of inertia of the remaining disk, it is going to be k into mr square is equal to so m dash we call it as m dash r square. So m dash is 3 by 4m into r square. So r square get cancelled. M and m get cancelled. So k will be 3 by 4. First option is correct. Moving to the next question. The ratio of the radius of gyration of thin uniform circular disc about an axis passing through its center and normal to its plane to the radius of gyration of the disc about its diameter. So therefore, get back the basic formulas of the disc. Moment of inertia of the disc about an axis passing through the center perpendicular to the plane. Normal to the plane is first case mr square by 2. Then making use of, when passing through any diameter means we have to make use of perpendicular axis theorem, ix plus iy. So I is going to be mr square by 2. Ix you treat it as, if you draw the circle, along x-axis you can take one diameter, along y-axis also you can take other diameter. So therefore, Ix can be written as about diameter x-axis, about diameter y-axis. So therefore, this is 2id. So moment of inertia of the disc about an axis passing through the diameter is mr square by 4 is equal to id. So now the question is ratio. First case is mr square by 2. All right. So the question is radius of gyration, I think. So you call this is mk1 square. You call this is mk2 square. Yeah. So m and m get cancelled. So k1 square by k2 square. Even here also m and m get cancelled. So k1 square is r square by 2. K2 square is r square by 2. R square get cancelled. This is going to be 4 by 2. So this is 2. So therefore, the ratio is root 2 is to 1. So last option is correct. when you cancel when you take the square right side, it will become under root 2:1. Fourth option is correct. Moving to question number 21. This is given in 22 NEET. Two objects of mass 10 kg, 20 kg respectively connected to the two ends of a rigid rod. So similar question we got earlier. Length 10 meters. Distance of the center of mass of the system from the 10 kg mass. So here first body is 10 kg. So get back the formula here. Same formula M2D by. Treat M2 as 20 kg. M2D by M1 plus M2. Yeah, so therefore, once again, R1 is equal to numbers are only changed, M2D by M1 plus M2. So M2 is 20 kg. Then D is 10 meters divided by 10 plus 20, 30. 0, 0 cancelled. So answer is 25. Yeah. Next. So in meters. Then next. Angular speed, question number 22. Angular speed of a flywheel just like this, moving with uniform angular acceleration, changes from 120 RPM to 3120 RPM in 16 seconds. The angular acceleration, simple question. So we got in translatory motion V equal to U plus AT. Similar equation in rotational motion is final angular velocity with initial angular velocity. Tangential acceleration becomes angular acceleration. This is the question now. Omega 2 minus omega 1 divided by T is equal to alpha. Then, so getting omega 2 in terms of, because they mentioned revolutions per minute means frequency given, but omega can be 2 pi by capital T. Because the reason is angular velocity, angular displacement by time. So for complete rotation, it makes an angle 2 pi radians, and for the time taken, it's now you are renaming it as time period. So therefore, omega 2 is equal to 2 pi f. This is for 1 second calculation. So here 60 seconds because RPM mentioned. So 2 pi into 3120 divided by 60. Therefore, I think so. This is roughly 30. Then next 0, 0 cancelled 10 times, and I think 104. So yeah, 104. 104 radian per second. Yeah. Similarly, try to find out omega 1. Same process. 2 pi f1. How much is f1? 1200 divided by 60. So this is going to be 30. 0 cancelled. Then this is 40. Now put the values in the formula. Alpha is equal to 104. So this is the formula. 104 minus 40 divided by 60. So this is 64 by 16. 64 by 16. So the answer is 4 radian per. So there is pi missing here. This is also to be represented with pi. This is also to be represented with pi. So therefore both will have pi here. So answer is 4 pi radian per second. Moving to the next question. I think it is similar. The energy of 484 joule is spent in increasing the speed of a flywheel 60 RPM to 360 RPM. The moment of inertia. So get back the formula of rotational kinetic energy. So W is equal to rotational kinetic energy, change in the rotational kinetic energy. Half I omega 2 square minus omega 1 square. So rotational kinetic energy already given 484 is equal to half I. The same process to get omega 2 pi into second case is 360 divided by 60. So this is 6 times. So it will be 12 pi. But in the formula omega square we have, so it is 144 pi square minus, try to get omega 1. So 2 pi with 60 divided by 60. So therefore it is 2 pi. So it is 4 pi square. Yeah. Now 140 pi square into I is equal to 484. So this is 70 times. Roughly this is pi square, you can take 10. So I will be equal to 484 divided by 700. The 70 into pi square is 10. 700. Yeah. Point 7 by 4.8, roughly 0.7, 0.6 you will get. So first option is correct. Moving to the next question, that is 24. I think so. This is the last question. Yeah. We need to find out the magnitudes of the both scalar and vector products. So get back the formula of scalar product. A dot B is equal to AB cos theta. So A is just like R and F is just like B. So 2I plus J minus K dot VI plus 2J minus 2K, or dot product when you take I dot I only we need to consider because dot product of unit vectors is 1. So therefore, you don't need to go with I dot J, J dot K. Yeah. So this is going to be 6 and this is plus 2. So minus of minus becomes, so K dot K is again 2. So this is the result of dot product. Now moving to cross product. So the process of cross product is R cross F. We will get first answer is initially in the form of vector I, J, K. So I is just R is just like 3, 2, minus 2. This is 2, 1, minus 1. So I, this is minus 2. That will be plus 2. Minus J. Forget about the column and row. This is minus 3 plus 4 plus minus 4 is into the formula. There is one more minus plus K into AD minus B. So this is 3 minus 4. So this is cancelled. This is minus G. Okay, this is minus. So, but this is in vector form. The process to find out its magnitude is ax square ay square is 1. This is 1. So the answer is root 2. So dot product is 10 and the value of cross product, magnitude of the cross product is the third option is 1. Thank you very much, students. In my next video, I'll continue answers for the questions given in the previous NEET exams from the chapter gravitation. Thank you very much. But don't forget to share and subscribe with your friends and relatives.